overall temperature and burn barrier. So basically that's a chart. That's one of the charts there. And we will pull up the other chart. Again, welcoming for all those who are tuning in to tonight's live stream here. So this is another chart here. This is the Canadian rules. The Canadian Core Rules, OESC Rule 4-004. And it says this rule states that when conductors are installed in an ambient temperature higher than 30 degrees Celsius, you must apply the correction factors from Table 5A to adjust their allowable ampacity. The sun exposure rule, OESC Appendix B, this code book especially notes that rigid non-metallic conduit PVC exposed to direct sunlight and will absorb solar radiant energy. This solar absorption pushes the internal air temperature inside the pipe at least 15 degrees Celsius to 70 degrees higher than the outdoor air temperature. So again, that is basically the charts there. I'm going to pull up other charts as I go along here, and we're going to continue here. Let's look at the actual code, section 4, or baseline calculation. Assume an ambient temperature of 30 degrees, but when you anchor dark gray schedule 40 or 80 PVC completely explodes onto a south-facing exterior commercial wall or roofline direct radiant sun exposure easily spikes the internal pipe temperature by an extra 70 degrees, pushing your internal routine climate past 50 degrees Celsius to 122 degrees Fahrenheit. If you check OESC tables 5A or NEC tables 310.15b, running your circuits in an environment between 46 degrees Celsius and 50 degrees Celsius forces a massive 0.58 ampacity derating correction multiplier on your wire. That means your heavy conductor that was safely rated for 100 amps can suddenly only carry 58 amps before installation completely melts down. If you don't upsize your wire gauge here, you'll fail your inspection. Drop 50 in the chat right now if you have ever opened an old outdoor junction box or meter base and found brittle cut wire installation that crack right off the copper. So tonight I'm going to show you guys some stuff here. Again, this is look right here at our physical layout panel. So look right here at our physical layout panel. Watch what happens when I track our surface temperature now. Look closely at these conduit straps. Not only does ambient solar heat cut wires, but it also creates severe physical expansion. So that's the box right there. It's scanning and it's went up by 0.1. This is the conduit. It's scanning. It went down. As you can see, there is no heat on it. So it's going to continue gradually go down. Same thing here. So again, PVC expands. PVC expands at a rate of 0.052 millimeters per meter per degree Celsius. Notice how I have deliberately left these strap screws back off a millimeter. If you clamp these down flat like a vice grip, your pipe can travel vertically, and it heats up also. It will buckle completely off the building's face and tear your connectors out of the wall or out of the box hop. These must act as guide straps to let the conduit slide into your expansion joints. So you see that? That's not even moving. Okay, so again, welcome back all you guys to the channel, and I'd like to thank you guys all for tuning in to tonight's live stream. So we're going to, like I said, I will run a couple of videos here also as we continue the live stream for tonight. Again, I'd like to thank you guys all for tuning in to the live stream, and again, don't forget to leave a like on the live as you enter. So I'm going to show you a video here, and then we're going to get back to the board. So again, this is the conduit that I'm going to be working with today, and as you can see here, I've got my core line cutters, I've got my tape. Core line cutters, I normally use them to cut my PVC pipe ends, and as you can see with the pipe here, I've got basically tape at the end here in order to stop the gravel from going in. And basically what I'm going to be doing is running this PVC conduit to the other end of the wall, and I'm basically going to snick this off like this with my core line cutters. And I'm also going to place some tape at the end of the pipe, that way it doesn't get gravel inside of it. This acts like a coupling, same thing. This is how they come, 10 length. You'll get the, some guys call it a bell-end, but this is what you call a 1/2 inch coupling also. Normally what I do at the end, I'll place around my glue around here, that way it's firm, secure. Twist at the end to make sure it's not moving. That piece is done, and then we're going to move on to the other piece.
I need my 1/2 inch cut point at the other end.
So again, welcome back. And this is basically what we have here to scan or conduit pipes and so on. So I'm going to scan and let you guys see. So that there is basically gradually increasing and decreasing. Now we're going to scan the light. So again, PVC expands at a rate of 0.052 millimeters per degree Celsius. Notice how I have deliberately left these strap screws back off a millimeter. If you clamp these down flat like a vice grip, your pipe can travel vertically as it heats up. So I'm going to run another video here as we go on here for the night. Again, welcome you guys, welcome brothers and also sisters into the live stream. Don't forget, as you guys enter, leave a like on the channel. So before I run the video, I'm going to pull up the actual rules. There are both the rules for both countries. So I will put them up here. So let's go with this one here. So, brothers, let's look at the real world math. Say you are running a number 3 couple with 90 degrees RW90 insulation. Under normal conditions, table 2 says it's safety rated for 115 amps. But you run that wire inside a dark PVC conduit. Strap flat against a south-facing exterior. Your 115 amp wire can suddenly only carry 6 amp before the insulator starts melting. If you landed that on a 100 amp main breaker, it's an immediate code violation and a fire hazard. You must upsize that conductor to pass code. So this is the tables here. It has the temperature, the ambient temperature, the correction multiplier, 90 degrees Celsius, wires, Fahrenheit and Celsius, 26 degrees Celsius, 78 Fahrenheit / 86 Fahrenheit, 31 degrees Celsius / 35 degrees Celsius, 87 Fahrenheit to 95 Fahrenheit. 0.96, 36 Celsius, 96 Fahrenheit, 104.9, 0.91 is the correction multiplier. 41 degrees / 45 degrees Celsius, and the Fahrenheit is 105 Fahrenheit to 113 Fahrenheit. The multiplier is 0.87, and 46 degrees Celsius to 50 degrees Celsius. Ambient temperature is 114 Fahrenheit to 122. The multiplier is 0.82. So the United States rule NEC, the core rule NEC RT, this mandates amplicity correction when conductors are operated in ambient temperature other than 30 degrees Celsius. The rooftop sun exposure rule NEC RT. The NEC is incredibly strict. Should conduit mounted across sun-baked roof. It states that if a raceway is installed less than 7/8 of an inch above a roof surface exposed to direct sunlight, a flat temperature added of 33 degrees Celsius to 60 degrees Fahrenheit must be practically added to the outdoor ambient temperature before checking the chart. And this is the Canadian rule, OESC 2024, the core rule, OESC rule 4-004. Number 7, this rule states that when conductors are installed in an ambient temperature higher than 30 degrees Celsius, you must apply the correction factors from table 5A to adjust the allowable amplicity. The sun exposure rule, OESC Appendix B, Section 4 notes. The code book especially notes that rigid non-metallic conduit PVC exposed to direct sunlight will absorb solar radiant energy. This solar absorption pushes the radiant energy. This pushes the internal air temperature inside the pipe at least 15 degrees Celsius to 17 degrees Celsius higher than the outdoor temperature. And this is basically the layout here. So I'm going to take that off. So again, welcome back to all you guys who are tuning in. And if you missed the opening of the live stream, this is basically what you call a digital infrared thermometer. It basically detects heat. So basically what you will do is you will basically turn this on. As you can see, you turn it on and you scan it, and the numbers will rise up and down, and it will basically detect if your conduit, if the wires in the pipe is overheating and so on. So for all those who are tuning in, I'm going to point this right here again. And as you can, if you lock in to my actual right here, you will see that it's got both Celsius, 15.7 Celsius, okay, and it's going up 15.9, 16, 16.2, 16.3, 16.4, 16. So it's going all the way up as I continue to point this here. And then I'm going to shift this over to the actual conduit, and I'm going to leave it on the conduit. And as you can see, it's shifting 15.4. So this is actually going up and down, in between, rising, coming down. So let's put it on the actual clip itself and see what happens. And then I'm going to go here onto the actual connector itself. Now the connector itself is going more than the actual pipe itself. If you can take a look at the connector, is actually 19.5 Celsius. The pipe goes right back down to 15 degrees Celsius. The box rises. Now let's take a look at the actual light itself. If I can spot it right in there. Now the light is going to rise because there's heat in there. So that light right now is actually gone up to 31. 31 because the light is hot. So the difference is the conduit, it stabilizes until you have your wires inside, but the actual light, for all those who are tuning in to the live stream, welcome them to the channel. Thank you guys all for tuning in. And again, I'm going to spot this on the light again. And as you can see, the light is going to skyrocket because there's power there. So if you missed the opening, I will show it before I log off. Again, for all those who are tuning in to the live stream, welcome into the live stream. I'm going to run another video here for all those who are tuning in. If you missed the opening of the live stream, you can catch this on the replay, but I will run the conduit video here. Really, to bring power into the home. So again, this is the conduit that I'm going to be working with today. And as you can see here, I've got my core line cutters, I've got my tape. Core line cutters, I normally use them to cut my PVC pipe ends. And as you can see with the pipe here, I've got basically tape at the end here in order to stop the gravel from going in. And basically what I'm going to be doing is running this PVC conduit to the other end of the wall, and I'm basically going to snip this off like this with my core line cutters. And I'm also going to place some tape at the end of the pipe, that way it doesn't get gravel inside of it. So again, thank you guys all for tuning in. This is basically installation of conduit and how I go about using the conduit and so on. This is how they come 10 length. You'll get the, some guys call it a bell-end, but this is what you call a 1/2 inch coupling also. Normally what I do at the end, I'll place
around my glue around here. That way it's firm, secure. Twist at the end to make sure it's not moving. That piece is done, and then we're going to move on to the other piece. Now I need my 1/2 inch buckle at the other end.
So again, welcome back to the channel. And for all those who are tuning into tonight's live stream, don't forget, as you guys enter, leave a like on the channel. And you can also catch this video on the replay if you miss the beginning or the opening of the live stream. So basically what tonight's live stream is about is basically knowing where to find the correction factor for derating your wires and so on. As we all know, the in this dead summer it gets hot, and the wires and so on will heat up. So a lot of times if you undersize your pipe, the pipe does not have no room for your wires to breathe, which is very important. Your wires need to breathe inside of the conduit. So let's say you have 3 number 6s running inside of a conduit. Most guys will probably use 3/4. I went with 1 inch for the simple reason is it's easier to pull. It's also a lot easier to breathe in. It has room to dissipate its power and so on. You don't want your heat to get trapped inside of the pipe, and that's where your wires will start to melt and so on. So very important when you're using when you are pulling conduit, when you are running conduit and so on, and you're strapping it dead front of the home in the sun, the pipe will absorb all of the heat like it's supposed to. Rigid PVC conduit. But you also have to keep in mind to also make sure that the wire size is big enough for is big enough, and it's also the pipe can breathe and so on. You don't want to have your pipe stuffed with wires where there's no room to breathe. You're violating your code. So again, if you check OESC table 5A or NEC table 310.15B, running your circuits in an environment between 46 degrees Celsius and 50 degrees Celsius forces massive 0.58 amplicity derating correction multiplier on your wire. That means your heavy conductor that was safely rated for 100 amps can suddenly only carry 58 amps before installation completely melts down. If you don't upsize your wire gauge here, you fail your inspection. Also, when it comes to above ground overhead service, let's say you're going overhead service, obviously you have to turn around and change out the wire. Is now has to be a ready for sunlight when it comes strictly outdoor and in contact with the sun. So basically what happens is your Um, your rooftop, when you're doing your overhead cables, a lot of times those cables are going to go into a loop, a drip loop, we call it. So after it leaves the conduit, it comes out into a drip loop. And what basically happens is that wire is exposed to sunlight. And when the wire is exposed to sunlight, it's going to derate, it's going to malfunction, and so on. If you, for instance, you're using T90 wire or TW75, those type of cables, you have to have sunlight resistant cable when you're doing your overhead cable and it lands on the outdoor where it's exposed to sunlight. So you're not going to pass your inspection just using regular cable. The inspector will fill the job. So very important that you have to have the proper cable to do the job. If not, you're risking a total failure on your job. And of course, we all don't want to fail inspection. Very important. Failing inspection is not really a must. You have to pass. So for all those who are tuning in, I'm going to, this is basically what this is. It's a digital infrared thermometer, and it basically will detect the heat inside of your conduit and so on, and it will tell you the temperature that it's at. And I'm going, for all those who are tuning in, if you missed it, I'm going to scan it and let you guys take a closer look here. So that's basically the pipe, and that's basically my box. Now, as you can see, it's a steady number. And then I'm going to shoot this on the light itself. So that's basically how you will go about using your digital infrared thermometer. Again, for all those who are tuning in to the live stream, I will run another video here. If you did miss this on the beginning of on the opening of the live stream, don't forget you can also catch this on the replay. Really, to bring power into the home. So I'm going to go over to the actual hole now where they're actually so this is basically the machine that we use. That's basically a structure that he's doing. And as you can see, he's going to be placing over to the actual pole where he's got to go. Basically the type of machine that he's using. Basically sucking away at the dirt. And I'm assuming that he's already drilled through from one side to the other. And what you're basically doing right now is pulling the conduit over to the other side. Again, from time to time, you'll see me filming my video to avoid having the other workers on the line. So I'm going to go up a little bit closer. So this is the machine that we're basically using to go across. Basically, he has to get to here. And he's got to get up to this pole. As you can see now, they're basically pulling this pipe over to the other side. So again, welcome back to the channel. If you guys are tuning in for the first time, don't forget to leave a like on the channel. So again, always remember to calculate your solar factors. Upsize your wire gauge when the sun hits your pipe. And keep your straps loose enough to let the system breathe. Now running your outdoor conduit to the exterior wall is only the first step. If you want to see exactly how to wire up a heavy 400 amp parallel residential main disconnect switch that these conduits runs LAN into, head over to my channel homepage right now and watch the complete phase 2 masterclass video I dropped this past Sunday. Hit subscribe, turn all notifications to all, stay safe on the job site today. And I'll see you brothers on the next drop. Shutting it down now.